Okay, it's a little bit small, but I'll let it work. Hello, I'm Patrick Suthi, and this presentation is about quickly creating prototypes for RCP applications. Actually, I spoiled myself. I'm a software engineer working for iTemis, and I'm also an Eclipse platform committer, which means I push changes to the Eclipse code base. And before starting this presentation, I would like to know if you are familiar with JAXB and JPA for Java persistence. How many of you are familiar with both JAXB and JPA? Okay. And I would like to know if you know about WindowBuilder and Eclipse E4. Okay, that basically hits the topic of the talk. So for this presentation, I'm using Eclipse RCP Oxygen 1 and some plugins, so Nebula widgets for charting and WindowBuilder to quickly build the user interfaces. Plus, I'm using some libraries to persist my data to XML and to the database, and a database library which is Apache Derby. If you think about building a prototype for a customer, I think about starting from the data model. I would start from the data model, and then I would add a persistence layer, and then I would test that this is working before starting building the actual user interface, a simple one, and then going more deep, building a complex user interface, and then running my prototype in front of my customer. This is an example of application that I built in a week that you can find open source. You can find it's an Eclipse public license on my GitHub, and I'll explain quickly how you can build the same. So let's get started with the data model. I used a very simple data model where we have a bank which has customers, accounts, and some transactions of different types. The only thing that I can tell about, well, you can generate the data model, but it's very important that you think at a mechanism for listening to the changes of this data model, because you then have to use it in your user interface. So in the case of Eclipse, it's a good practice using property change listeners. And when your data model is complete, you can, when your data model is done, it's better, I generally write some test data to verify that that the data is actually working. I can build all my account, transaction, whatever, and then I test this data. So to verify that the model it's working. When I'm sure that the model is working, incrementally I start adding some annotations, because I want to save the model to XML. It's a simple file format which is accessible by anybody, and basically it's pretty easy to add annotations to your data model to transform it in XML. And there you can see some of the let's say most useful annotations for corner cases, not the XML root element, but for example, you can see how you declare an XML attribute as an ID as an attribute. You can see how you can declare aggregation in your XML. Instead of containment, as opposite as containment, you can basically point to a list of existing elements just by their ID. Or you can have subclasses which you don't want to have in different elements, but in just one element. When you put all your annotations, your saving and loading XML is quite easy. You just need four lines of code for persisting and for saving and loading. You need a marshaller and an unmarshaller. And to the right, you can see the resulting XML, where I marked the, let's say, some of the corner cases that you can find. So, for example, an ID attribute for the customer, or an aggregation ID list for the accounts. So you see that the accounts are not contained as XML elements, but as a reference to another element, which is actually just below. And so on. On the bottom, you can see subclassing on XML. So with just this annotation, you can save and load your data model to XML. That's good. Let's add more. Let's add JPA annotation, Hibernate, whatever. You want to save and load your data model to the database. And then, again, I put on this slide some corner cases. Let's say the one on the top, it's interesting, and you use it when you have a base class that you don't want to persist as a table, the mapped superclass. Entity is quite straightforward. That means your class has to be mapped as a table in a database. And then you have other annotations, like a one-way association, so a foreign key, with the one-to-many annotation. You have, there you can see the single table inheritance. So basically, before you saw that we have a transaction with 4 different types, but you don't want to use 4 different tables. You would just want one table with a column that says which type is it. And that is where you use the single table inheritance. And below you can see like the specific subclass specifying its discriminator value, its discriminator column. Again, when you added the annotation, it's pretty straightforward to save and load your data from the database. And this is the database that I auto-generated. It's pretty small. There are not many association classes. And there are, yeah, I wanted to keep it small. It was just a prototype. When my prototype is working, it's time to start thinking at the user interface to sell to my customer or to make for my open source friends. And then I'm fluent with RCP. I just create an Eclipse RCP application. You create a new plugin project, and you start structuring the application with the model editor, which is in this figure. And then you create perspectives. Let's say a perspective for each aspect of the application. Now we go a little bit more in the details of your application. So when you start your application, it's if you want to use the model in your application, it's better you put it in a reference in the application context, not a generic context which is a tree object, but in the top level application context, which you can always access through the application object. And then you basically send events every time you define and send events through the Eclipse framework, every time that your model changes. For example, below you can see how the user interface is accessing, is executing code after a model change. It declares an injected method which listens for this UI event topic with the same name that you defined in an event class. So on the code above, you see how we send an event, and below you see how the framework allows us to use quickly, to basically to call this code when the event is fired. So once you did this, you have your data model in your application, and you can start structuring the application with the E4 model editor. Quickly said, each Eclipse application has a model that you can access at runtime. And the E4 model editor is a tool for developers to quickly create your application. To the right, you can see handlers, comments, and a menu. Basically, what happens is that your menu, it's linked to handlers, which are actually classes executing your commands. And the command is an abstract entity that can be reused everywhere in your Eclipse application. On the left, you can see like the user interface, how I structured the user interface of my RCP application with some perspectives. And inside the perspective, you see part/containers, which are containing the view, and parts, and to the bottom, to the extreme bottom, you can see that a part can also have a toolbar and tool controls, so a small widget on the top right of the part to perform certain tasks. This is an example of the resulting application, well, of one of the perspectives of the resulting application. A perspective with the two subparts, one to the left for searching and one to the right for editing the data. If you look at the previous slide, can I go to the previous slide? Oh, come on. We saw basically that this perspective here, it's the customer perspective with this icon, which we defined here. And it was automatically created by the IDE. We saw that we have a part/container with a vertical orientation with two parts, customer search and customer detail, which are actually here, customer search and customer detail. And with this UI, with this perspective, you can search here, select a user, and edit actually the user. Later I'll show you that any edit that you do here, it's linked to all the other parts of the model, because I used property change listener to keep the model alive and submit notification to the other parts of the UI. Building the UI, it's very simple with WindowBuilder. I mean, it's not the perfect solution, but we are prototyping. So I want a quick application. I want to build it quickly. You have a visual designer in which you can drag and drop components. You can see the hierarchy of your UI. Basically, there are layers. There is a big layer containing a label, which contains another layer called composite, and so on. Plus, you can define data bindings with WindowBuilder. So you can specify how your UI is bound to the data that it's in your model. And after that, you have to manually encode your user interaction. Let's say how you initialize the model. Is it initially empty? It has some data. How you react to model changes? What happens when I click on this? And what happens with I change selection? In the previous case, when I select something, it is in this view class, view part class. Also, the other view part class can react to that change. And this is a framework stuff. And also, you have to basically react to events. I can show you a demo of how to build a simple UI, but you can see that from my badge that I'm stressed. So I prepared a video that I'm going to comment. Hope you can see this. It's just 4 minutes. If I can put it here. No, I cannot. Wow. Let me try to do probably this. Okay. So here is the WindowBuilder interface. I try to describe what happens. I'm going to create that user interface on the right, and I delete all the tree. And I start adding a composite using the grid layout, which is very important because you can lay out components in a grid. And then in this case, I'm adding a label, which I want to span, to grab excess horizontal space. And then I add other composites, so containers, which in this case contains a label, if I'm able to put it there. And basically, you can see that it's nicely placed in a grid. You can also change the name of the variables, which then you have to use in your own code. And then you can basically stretch elements. I try to fast forward to explain what is happening. Basically, I'm adding checkbox buttons in this nice layout. Well, it's almost done. But I'm adding other checkboxes. Let me see if I can. So basically, I'm adding other checkboxes for filtering customer name, address, and so on. And then I'm adding 2 buttons. Well, adding buttons is nice. So basically, I'm adding buttons. I'm giving them the names. And then I'm adding a list on which I want to display the search results. After I added the visual components, I also need to bind them to my actual data model. The data model is any data which is available in your UI class. So basically, you can see on the bottom of the application, there are 3 tabs: source, design, and bindings. Well, basically, the bindings tab allows you to link the properties of the widgets with some data. Now let's, you can also test the layout and so on. Now I think I'm going to switch to the bindings, yes. And basically what you do, you have a target on the left and a model on the right. Basically select an object from the target, an object from the model, and then you create a connection, a data binding connection. You see, select an object, select its property. For example, the button account ID selection property is linked to a filter object with filter name. That means that when I click this button, my filter has a Boolean value that allows me to filter the name, and there is customer name, customer address, and so on. I fast forward a little bit until you get to the list viewer. Well, buttons, they don't have a representation in the model. You execute action through buttons, but you see the list viewer input. It's going to be linked to my get model. I think it's accounts, no customers, whatever. I don't remember what I was building. And when you add this binding, you can actually select the element bin class. Now I stopped the video. Basically, it's one of the classes which is on your model, of which you can even select properties. But let me stop this video, if I am able to exit this. Is it this one? Okay. Which one? Okay, thanks. No, that wasn't this one. Anyway, yes, this is QuickTime. Okay, I don't need the video anymore, but if you are interested, I can show you live something later, how we bind objects to lists and tables. Actually, that was my plan from the beginning. So we saw, okay, We saw how to build a simple user interface with WindowBuilder, and then we get into its interaction model. So the code that you have to write, it's here, so tomorrow you can get to this slide and reuse the same code. In my case, I'm using a setModel method to check if the model is currently null, the model for my view. If it's null, I do not have to execute on my UI. And then if the bindings, which are these links between my UI and the models, are set to something, I want to dispose them. It's basically something that is needed. And then I set again the model, because when I set a new data, then a new data model, let's say, I can set new bindings. New bindings between this new model and the still existing UI. I don't want to change the bindings one by one. I just want to create new bindings. And in this case, to check if my user interface exists, if it was built by the framework, I check if one of my components, in this case my main component for listing the things, the list viewer is null. And then I initialize the data binding and I call an update method. That was the worst part for me. Anyway, you can see, you can check in the source code how it works, and you can change it if you don't like it. After initializing the model, you need to listen to model changes. The framework gives you the possibility to listen to events that you fired somewhere. When you change the model, let's say, you fire this event, and then you put a method with this signature, inject optional, UI event topic, and then the name of the event that you fired when you changed the model. And this method, this update, this code is called automatically by the framework through injection. Then you have to have your interface, user interface, react to events, to the selection. What happens when you select a list on the left hand side, in the left part, you want that the right part executes something. So in this case, I will inject a selection service, which is provided by the Eclipse framework, Eclipse C4 framework, and then you just, in your code somewhere, you use the selection service to set the selection. Well, actually, I'm setting the selection, not listening. I pasted the wrong code. But you can easily listen to the selection by using an injected method. So it's pretty straightforward. Again, you will have an injected method like it was in the previous slide with the selection, and when it's changed, you check for which object was changed, and then you execute your code. If it was an account that was changed, you update the account part. If it was a customer, you go with the customer. And then you have widget events. This is pretty straightforward. You add the selection listener, and then you execute whatever. In this case, when I search, I just update the user interface. To the next slide. This is a second perspective which I built with a little bit more complex user interface. It doesn't look like, but I can. Okay, this we will have a chart here, and here we will have a table. You can see that WindowBuilder displays you the columns, and also this is a table, and still let you see the component which will be holding the chart. In this case, my update method is a little bit more complex. I have to refresh the table viewers, resize the columns because they are not equally sized. So I am doing that manually. And then I'm calling this chart helper, which generates the graph. Roughly speaking, you see LWS. It's a lightweight system linked to the canvas that you can see in the empty space. And this is the object that we can use to draw a chart on top. So it's pretty simple. Well, let's look at this. Where is my Eclipse? I think it will be kind of, yeah, that's a bit, ooh. Okay. But anyway, what I have to show you is just table naming for now. So the simple UI was the account search part. We go to the account detail part, which almost and let me do this. It's probably on the Mac, Control M. It's too big. Let's try with this. Okay. So basically, we go back to the design, and we have this account. Yeah, whatever. I don't see the canvas. It's here. Okay, it's very small. But anyway, we have a table with 2 columns, which are bound with data binding. In the data binding, we can explore the binding, which basically understand which is the bin element, so which is the element corresponding to each line of your table. And once he identified the element, you can access public properties and put them as columns of your viewer. That is pretty simple. You just need to create a binding and then use it. I'm going to close it. Back to the presentation, if I can. Yes. Okay. Here is how I add charts. So I had an empty spot with a canvas where you now see the chart. And then I simply create this lightweight system based on the canvas. Yesterday, on the train, I was trying to convert my application from Windows to Mac, and I discovered that it's better you keep only one lightweight system and not create it every time, because on Windows still works, but you are basically creating new objects all the time, and it's a little bit slow. On Mac, creating the new lightweight system every time, it doesn't work. So my solution is to put this lightweight system always in the create part control, in the create part method, so you don't waste memory and our application works also on Mac. And then generating the graph is quite easy. If you have a reference to your lightweight system and a data object, you just create an XY graph, which is from Eclipse Nebula widget. You set a title, you create a data provider which holds the series that you'll see here, and then you create this new trace with your data provider. For this slide, I strip away some code lines, but you'll find everything again on the source code. Okay, with this system, basically, I already showed you the customer perspective. I'm showing you like the accounts perspective. So basically, you can search an account, select one, see the chart, see the table, and basically what you see here is linked to the current selection. The transaction also is basically the same. You can search, edit, let's say create. You cannot see the widget that I added here because it's an outdated picture. But you can create a new transaction, process, execute some data which is basically stored in the data model, and that's it. So at this point, if I still have time, I'm going to show you like the working application. Hopefully it will fit here. Cross my fingers. Okay, it was on the other screen. Okay, are you around? Unbelievable. So this, it's the Mac, okay. I have to not exit, but okay, make it smaller so I can use this like a normal desktop. And then, okay, I'm not really used to Mac, as you can see. Okay, So basically, you know that the menu, it's on top here. So basically, it's where I have save and load. I have a list of customers, which is, this is basically a thing that takes the images that you put on your data, on your application model naturally. You can select accounts. Let's say you can select a customer. Say you want to select Tom Jones, and then the selection is automatically filtered for you. Let's say if you select Tom Jones and you decide that it's called Tom Jones, you see that this is updated here, but also on other perspectives. And it's pretty snappy. I mean, I really like it. I think in this demo I'm going to show you also, for example, let's take this Alex Michelson, which has no transaction. Basically, it's at 0 in his balance. I go to the transaction page. I don't see any. Like the last one is 1,000 euro. I create a new transaction, which is a deposit of, let's say, 5,000 whatever. There is no currency here. I search because I can access all my data models, so it's easy to replicate the data. Was it Alex Michelson? Yes. Okay. And then I can create this transaction, which is not yet here because it's not processed. But if I confirm and process it, oh sorry, it was the last one. If I confirm and process it, that is a prototype. I probably can see that Alex Michelson has now more money, you see? Well, it wasn't visible before, but I can give you a proof that I'm not lying because I'm now loading some data from the database. And I think here Mr. Michelson has like a lot of money. And in the same way, you basically can save to XML. So, for example, or load from XML. For example, let me try to, okay, in this case you see that I have really a lot of transactions, but if I load from XML another data model, whatever, this one, I have less transactions and probably a big transaction on the bottom. So this is a very simple prototype, which won't take long for you to build or to modify, because you have these slides and the code. Concluding, that was a quick way to create an application, and there are some tips on how you can persist your data, how you can create your user interface with Eclipse RCP. And you can find the source code is under Eclipse Public License. And you can, if you want more, I'm working for Itemis, so it will be great if you need professional support to get in touch with Itemis. And well, if you are looking for a job, we are also searching for bright minds. But that's basically it. At this point, I would like to know if you have some questions on the topics of this presentation. Please.
You introduced your approach where you did the back end first and then the front end.
Yes.
You're prototyping user interface here. Isn't there a good chance that new requirements will emerge during the prototyping phase, which you then need to change your back end to meet them, and then you may have built-in back end features in the data model that aren't necessary for the front end, yet you covered them with a test suite before finding that something wasn't actually needed.
If I understand correctly, you're asking what will happen if after prototyping the customer asks me to change the backend model, and what are the implications? The answer is, well, I could have generated all the model classes. You use Xtext, and with a simple language you can generate everything. And then if you want to change them manually, you can just update the user interface. And again, WindowBuilder, it's mostly for prototyping and also to use as a guideline to create your UI, because writing manually the code for a UI to achieve a certain style can be painful. So it's a guideline. I hope I responded to your question. Any other?
Yeah, that brings to my question. How much of your code can you use? I mean, WindowBuilder code.
Well, let's be honest. WindowBuilder needs some love. So we are an open source community. There are not many people supporting WindowBuilder. And so it writes outdated data bindings. And you basically can't touch the data bindings. Actually, you can edit the data bindings created by WindowBuilder using the new style of data binding. But then you have to change the name of the method, so WindowBuilder won't write on that. And the code that WindowBuilder generated, it's yours. You can edit. I mean, how much can be used? It really, if your user interface gets very complex, you get to a point in which you cannot use anymore WindowBuilder. But WindowBuilder, it's for quickly creating a prototype, for sharing an idea maybe, and also if I have to create a professional user interface, I first use WindowBuilder to lay out the things like I want, and then I probably go and write my own code, trying to keep WindowBuilder able to get back to that code and to render the user interface, which is not always possible. What else? Sorry, I got in a rabbit hole. Do you have other questions about that? Okay, so thank you very much for coming, and don't forget to evaluate the sessions.